Welcome back to the second part of our introduction to Spring Data Neo4j RX. Last time we showed you some features of SDNRX by creating the simple application. So we presented how to model your data to represent the graph, all the nodes, the relationships. Then we showed an example how you could provide the data to the user base by creating a controller. But the most important bit is, of course, the data access. For this, we created a Neo4j repository. With this special kind of reactive Neo4j repository, we accessed the movies. This is the common way to access data in Spring Data Neo4j or in Spring Data in general. But if you have not the fortune to work so domain-driven design-centric, there are other ways to access your data within SDNRX. First, let us have a look on how Neo4j. But first, let's have a look how Spring Data Neo4j is built up architectural-wise when we're looking at the data access. So, as you can see, we have on top our Neo4j repositories. And in the bottom, Neo4j Java driver. The in-between layers, Neo4jClient and the Neo4jTemplates, are additional classes or interfaces we introduced with SDNRX. You can think, if we go from the bottom to the top, of the Neo4jClient as a tiny wrapper around the Java driver. A Neo4jClient is something that helps you to prepare the queries and map the result data to the type you want to have in your Java application. For this, it needs the information about the type you want to get as a result and how to map the data. So this is basically a function you provide. If we go up one abstraction layer to the Neo4jTemplate, you can see, or you will see, that it does most of the stuff for you. So a Neo4jTemplate just needs the annotated classes and knows how to map these classes and create an instance of these in the application. So why should you use one of those? First of all, the Neo4jTemplate would make sense to use if you have not such a strict access as in repository-wise domain-driven design sense. So if you want to, for example, and we see this later in a bit, a person that does not have a repository in our application, because you just need a person in some corner case of your application, you would go with the Neo4jTemplate, because, as you might remember, a repository should only be used if you really want to access the aggregate root. If we go down a little bit more to the Neo4jClient, for example, you have even more raw access to the data. This is for something like Pojo, where you want to map just for once, for example, data. So you do not have the annotated classes at hand, but only a more or less value holder object or a DTO. In such cases, you have to provide the manual mapping function to create an instance. So for me, it's always the easiest bit to look into the test classes to show you how to use them. First of all, we take a look into the Neo4jTemplate. As I said before, we were working reactive-wise, so I would go with the reactive Neo4jTemplate in this case. So we can still benefit of all the test support we get from the project reactor framework. So we create another nested test to have a nice structure. And can write our own first test. So for this, just to show you how the API looks like, we just want to find all the people that are in our database. So I query everything for the person class. As you might have seen, we have all the quad functionality you would expect from such thing like a template already built in. So they find all specific type from a class that has all the mapping information is most of the simplest one we can do. So we just decorate everything with a step verifier. And because I just know this, we expect now to get 133 persons out of the flux. And after this, the flux terminates. So if we run this test, you can see that it will run green. So, but that's not the usual use case to do something like this. Of course, there can be places where you just want to find a concrete person by one ID or multiple IDs. But most of the time you would go with custom queries for this. To support you when writing custom queries, we decided to expose our Cypher DSL to you. So to get an idea how this would look like, we create another test where we want to find all the people who are acting in the matrix. So the Cypher DSL is some kind like an object-oriented version of Cypher. For this, we have some builder-like pattern. So we start with a match where we want to query, for example, or in this particular case, for nodes with the label person. And we just name them to reference them later. So P for person. So this would match, for example, all persons in my database. To have it more handy, we just extract the person node and also create a node for the movies, because we just want to filter for the movies that are named matrix. So with this version, we can then say we have a person, we want to match a person node that does has a relationship to a movie node. And then you can all see this on the parameter list. We can specify several types for these relationships. For this example, we just want to create one relationship that is called acted in. So we do get all the actors. After the match part, we can narrow our set of returned nodes with a where clause. Also, the where clause does this more or less in an object-oriented way. So we can then say our movie node, its property title, has to be equal to, and now we create a string literal of the matrix as a comparison value. After we've written all this, we want to return all the person nodes. As you can see, this is pretty much all you need, and you are somehow type safe or syntax safe, we would say, because our types in the Cypher DSL only allowed you to append the correct functions. So after we've done this and called the build method, we do get something we called a statement. So this is our query statement now. With this statement, we can then say to a Neo4jTemplate, please find all by this statement, and this maps them to this specific type. And after we've done this before, we wrap everything in the step verifier and then expect all the 5 actors to be present in our result. We rerun this test and you will see that this works. So while this is running and you can see it's getting green, I told you that this is something for corner cases. Usually you would go through the movie repository and then query such persons over the movies. But there are places in business applications where you can't do this. So this should help you to map your already described data. But let's assume, and for this example, this is somehow a little bit made up, but you will get the impression that you want to query for data that is not really described within your models or entities, like this, like the person that is described as a node. So let's have a short look into the database. Just a second. And we can see on the movie matrix, for example, we have mapped data for all the actors. We also, did this last time, have mapped all the directors. But what's about a producer? So let's assume that a producer is something completely different, for example. It's not a person, it's a producer. So we create a new class called producer. And as I said before, this class is more or less a value holder or a DTO. So it does not need any mapping. But how do we get now the data from the database in an instance of a class called producer? For this, as you hopefully remember, we use the Neo4jClient. And also in this case, we take the reactive version of it. So we create a new subclass in there to have nice structuring. And we would then, first of all, create a test to look into the API of the Neo4jClient. So the API is very lean. You can query with a Cypher statement, or for example, a supply for a Cypher statement. Let's leave the delegate 2 alone for now. So in a usual case, you would create now your custom query without using the Cypher DSL to have some more functionality in there. So we now query for the producers. true, and all the producers of the matrix. So this query, let me copy it, put it into the Neo4j browser, will exactly return me one person, Joel Silver. So, because we are already ready for Neo4j 4.0, we have to specify the database to query in. But as you could imagine, this is maybe due to changes if you want to keep up with compatibility for the 3.x line. So now we can more describe what we want to do with the Neo4jClient. We then specify we want to map everything to so-called class producer. And now comes the most important function. We define how to map the data. So now we use the map by function that takes two arguments or provides them to our code. The type system we are working with and the record. Most important for us is the record right now. But there are some cases where you have to rely on the type system. And this is the type system that we provide through the Neo4j Java driver, plus additional mapping functionality or converting functionality we have in SDNX. For this example, we do not need it. So let's go back to the browser for once to see what we do get returned. In a visual way, we know we get the node Joel Silver, but how does it look like when the data gets returned? For people who are using Neo4j for some time, it's not surprising. So we return P, that's the named one for the persons or the people, as a row name, because we do not have an alias or something like this. And within this, we could have several entries for the producers. So we would then, when we access the data, fetch the column P. Sorry, I said row before. The column P, and then access the name. So for this example, we would go into the record we get back, get the P column, and within them we access the result map name. So we have then our producer name. So usually you would go with a more sophisticated function, but for our example, this is enough to work with. So, but I do want to change something in the producer and allow it to take the name as a constructor value. So I can then say producer name, do this final, because I do not like mutable data. If we need it later, we create a getter for our name. And since we are here and we need to test, I just generate an equals and hash code function. So now we can say what we want to have returned. So all would create, of course, a flux with every entry. First, we'll just peek into the result set and return on the first value or signal it sees. And one does wait a little bit longer to see if there's really just one result. So one is more enforcing version of first. It will fail if there's more than one or no result. So, but we want to have all of them. So we have now the producer publisher in place and can then wrap it into the step verifier again. And we have already seen this in the database. We expect next a producer who is called Joe Silver and nothing else. After this entry or signal, we are just waiting for the complete signal. So while this test is running, I can tell you that the whole SDNRX infrastructure is built upon this way. So we do not have any access from the Neo4j repository directly to a Neo4jClient. We are using exactly this architectural picture in a strict version. So a Neo4j repository can only access the Neo4jTemplate, which then only accesses the Neo4jClient. And only the Neo4jClient communicates with the database through the Neo4j Java driver. So in this particular situation, we eat our own dog food. And as you can see, also the lowest abstraction we provide in Spring Data Neo4j RX runs perfectly fine in this case. And that's all I wanted to show you today. I hope you had fun and got some information and are still eager to try out SDNRX. You can get all the information in the description underneath the video, and have a nice day. Bye.